Learning checkpoint 1.4 is found in the OHS. And we're going to start by looking at questions 1 through 3, kind of all at the same time because they are related and they're super short questions. So the first one, number 1, says, what is the common difference, or D, of this sequence? So when we are looking for the common difference, we're looking at what we are subtracting as we move down the list from left to right. So you should start with -15, figure out what you are changing in order to make it to -4. And then what are you doing to make it to 7? What are you doing to make it to 11? And then 29, and so on. One thing that I'm noticing in this list of numbers is that the values get larger. So I know that my common difference is going to be a positive number. You just need to figure out which positive number it is. Number 2 says, what is the 8th term in the sequence? We talked about what the variable n stands for in these problems, and n stands for the term number that you care about. So if I'm asking about the 8th term, that means that n is going to equal 8. So you need to evaluate this equation and say that the 8th term, a sub 8, is equal to 25 minus 3 times n, or 8. And you need to use your order of operations to simplify this down and generate the 8th term of your sequence. Number 3 says, which answer is the explicit rule for the sequence 15.5, 13, 10.5, 8, 5.5, 3, and so on? I've snipped something off of your formula sheet that will be given to you on the end of course test. You do not need to memorize the recursive and explicit rules for the sequences. It's not a bad idea to memorize them if you just want to, but they will be given to you. This question says, what is the explicit rule? That means we're going to come through and we're going to be using this one right here. A sub n equals a sub 1 plus n minus 1 times d. Now the two pieces of that formula that we need to fill in are a sub 1 and d. We need to go find those two things. So a sub 1 is going to be the first term that you see, and then d is going to be the common difference, or the number that you are subtracting as you move down the list. So let's take a look at what we've got. The first term is literally just going to be the very first number that you see in the list. So the very first number that I see in this list is 15.5. And then the common difference, let's look and see what we've got. I'm starting with 15.5. All my numbers are getting smaller. So I know that my common difference is going to be a negative number. It's what we add as we move from left to right. I think I said subtract earlier. So I want to figure out how far apart my numbers are from each other, and I can use my calculator to figure that out. So I can do 15.5 minus 13, and I will get 2.5. So now your responsibility is to take the 15.5 and -2.5, plug them into this formula right here, and simplify it the best that you can. So you'll put the 15.5 right here. You'll put the -2.5 right here. And please remember that this shows multiplication at the end of this expression right here. This d is being multiplied with this entire set of parentheses. So please be very careful when you go to plug that -2.5 right here, that you're actually showing multiplication, not subtraction at the end of that expression. Number 4 is a word problem, and it says Reggie has 195 trading cards in the first week. Each week he purchases 16 more trading cards, and I want to know how many he'll have in the 12th week. We can actually solve this problem by using the explicit rule for our arithmetic sequence, and the reason that we do the arithmetic sequence is because we are adding over and over and over again. It says that each week he purchases 16 more cards. So every week he adds 16 cards to his collection. If I want to know how many cards he has in the 12th week, that means that n is going to be equal to 12. I care about the 12th week only. We'll start by writing the explicit formula. That means we need to go find the first term, and we need to find our common difference. I know that my starting point is 195 cards, and the common difference is 16 cards. We are adding 16 cards per week, and then I also know that the week I care about is the 12th week. So when you go to plug into your explicit rule up here, I'm going to plug in all of these pieces. You are going to need to simplify it to get the right answer. So, whoa, hang on, let me undo that drawing. There we go. The 12th term, or the number of cards at the 12th week, is going to be equal to 195 times 12 minus 1 times 16. And I just realized I wrote this incorrectly. Let me, I forgot my addition sign. It is not all multiplication. There we go. So now my formula exactly matches the one that's given to me right here. I'd forgotten to write my plus sign. So you need to use your order of operations here to simplify this all the way through, and you will get one of these answer choices when you do that correctly. And the last one, number 5, says, what is the recursive rule for a sub n equals 4 times n minus 1? What we need to do is figure out how to transform our explicit rule into our recursive rule. And there are a couple of ways that you can accomplish this. The first thing that I'm going to do is take that explicit rule and I'm going to simplify it a little bit. So the explicit rule says a sub n equals a sub 1 plus n minus 1 times d. I'm going to rewrite that as a sub n equals a sub 1, or the first term, plus, and now I'm going to simplify by distributing. I'm going to have d times n, or my common difference times n, and then minus 1 times d, or plain old d. And if I rearrange that green formula that I just wrote, what I'm trying to do here, guys, is make it match what was given to me. I've got 4 times n minus 1. So what I want to do is rearrange the green formula to match this formula right here. And that way the pieces will line up and I'll know exactly what my common difference is. And I will also know exactly what my first term is. So when I rearrange this, I can write the d times n first, and then I would have a sub 1, or the first term, and then minus d left over. So I'm going to put this last little piece in parentheses. A sub 1 minus the common difference is going to be the number hanging on the end of my equation. So if I match up the pieces, I was given 4 times n. Well, that 4 is in the place of d, or the common difference. So I know that my common difference is equal to 4. I'm going to just write that down here at the bottom so I don't forget. My common difference is equal to 4. I also know that my first term minus the common difference, so if I work backwards one place from where I started, I'm going to get negative 1. So negative 1 is going to come before the first term in my sequence. So in order to find the actual first term, I need to add my common difference to that value. So my first term is going to be that negative 1 plus my common difference, which is equal to positive 3. So now you have the pieces that you need to fill in the recursive rule that you see right here in this first line. I'm going to take d equals 4. I know that my first term is 3, or you can say that the term that comes before your first one is negative 1. So there's a couple of ways that you could say it. You could also say that a sub n minus 1 equals negative 1. And so right here you have multiple pieces that you can work with to fill into this top formula right here.